right, thank you very much for the introduction. Yeah, I'm standing in for Randy Moore. I don't know if any of you know Randy, but he decided it's going to be too cold here today to be here, so I'm just kidding. Work for Utility Service Company Incorporated. Just to show you a few slides, two slides, a little bit about us as a company, and then we'll get into really how we got into ice pigging or why it's part of our services, and then talk more about it from a technical standpoint. Utility Service was founded in '63 in Pittsburgh, Kansas. We've been an ongoing organization since '63. Started out as a painting company. And around 1985, we introduced what we call asset management program for water tanks. Basically, we take responsibility for the tank. What that did was put us in a situation where we entered into a lot of long-term relationships with customers. We've got customer relationships going back to 1985 with a lot of tanks. In 2007, we started getting into providing services to help our customers manage water quality. They're really stemming from what we do in the tanks and long-term relationships we have with customers. And water mix was really the addition of active mixing, keep water tanks circulated, chemical cleaning for biofilm removal, and all because of stage 2 disinfection byproduct rule, and people looking for solutions. In 2008, we were acquired by a company called Suez Environment. Suez Environment basically water, wastewater, and environmental services. And this year, we've launched now in the U.S. ice pigging of what we call TRS, which is trihalomethane removal system in the tank. Last slide on the company. About $150 million in revenue, and again, nation's leader in tank maintenance. We're a nationwide company. Got 45 salespeople across the U.S. in about 44 states, 10 service centers nationwide. We have over 2,000 customers that we have a relationship where we have our tank maintenance program, asset management program with, and that represents somewhere over 5,000 water tanks that we maintain. The company does over 1,000 rehabilitations a year and does over 7,000 inspections a year. And just over the last few years, we've installed over 260 mixing systems in the tanks. And again, now we're on the water quality side, and we do over 200 chemical cleans a year, both in the water tank as well as water treatment plant with filters. A lot of what we do is, to me, is kind of a best housekeeping, best practices. It's a practical approach to helping with not only managing the tank asset, but managing water quality. And simply, from my view, typically inexpensive tasks that avoid high cost issues and maintain the best possible environment. Examples. To me, if you keep your workplace, your home clean, uncluttered, clean things like gutters, you shovel your driveway so people don't fall or your car doesn't slide off the driveway and hit it. These are all simple tasks, right? These are just common housekeeping tasks. In the water system, it's very similar to backwashing water filters in water treatment plant. And for water tanks, cleaning water tanks, securing vent screens, locked access points, both hatches, entry points. These are all kind of simple, inexpensive tasks that do end up having impact on water quality. Proven tools or process, often proactive. I think that's one of the key things, that provide desired results while minimizing cost. And some examples: preventive maintenance. You change oil, tires on the car, painting your house. And for water systems, go back to asset management, whether it's maintaining that water tank, proactively painting it, exercising valves, having a maintenance program on pumps, whatever that is, or proactively maintaining the assets in the system. Best practices change, and they're not always the same for everybody. Certainly driven by new innovative technology. Look at the music industry. Gone from LPs, 8 tracks, if you even considered that a technology, tape, CD, now it's iTunes. It was all driven by convenience and quality. For water systems, again, driven by stage 2 disinfection byproduct, stage 2 water quality rule, people are looking chemical clean. Why? Because just pressure washing, moving sediment in the tank wasn't good enough. Okay, removing biofilm required addition of chemicals. Tank circulation and mixing systems. Continuous homogeneous quality in the tank, eliminating thermal stratification. Disinfection byproduct removal, specifically THMs. So we got to get to ice pick. That's how we got to where we are, which is really providing tools, sometimes just very simple tools like inspections, to more kind of advanced things like THM removal, and now ice pick. And those changes are all driven by regulations. So is clean water entering the tank? You've tested it. You've tested out of the water plant. What about in the tank? And one of the things when you're testing the water in a tank, are you getting a representative sample? What about the water quality of the customer's tap? Bottom line is you spend a significant amount of money, both capital and expenses, in producing clean water that's compliant. Now you put it out in the system. What happens? So the focus turns on distribution network, tanks, mains, and pipes. So water quality in the tank. Okay, I've got clean water coming in. So you've tested it, you know what it is. Is it clean coming out? How do I ensure it's clean coming out? A lot of things happen in a tank. Every time water sits, something bad happens. One of the things that you want to do is clean that tank periodically. AWWA recommends, I think, every 3 to 5 years. Sometimes, depending on your system, you want to clean more often. What about having consistent quality in that tank? Tank water will thermally stratify. And one of the ways to do that is to mix that tank. Right? Keep water moving, there's less problems. So clean tank criteria: stable disinfection levels, low disinfectant demand, clean sediment and debris. This clean sediment requires periodic cleaning. The reason why I've highlighted these, you'll see in a second. Debris requires that that tank interior is protected from the environment. Talk about vent screens, lock hatches, things keeping that tank secure. Requires regular inspection. And we talk about chemical cleaning because not always, pressure washing is not always good enough. And then the impact of the coating system. A sound interior coating system is going to give biofilm, biological organisms, less chance of anchoring and growing in your tank. And the reason why I highlighted those 3 things, in the tank maintenance program, there's 5 key components. 3 of them impact water quality: security, sanitary, and coatings. The other 2 are safety and structural. But the tank definitely is part of water quality management in your system. Consistency in the tank. Can I take a representative sample of that tank? If I know it stratifies, how do I make sure I get a representative sample? And the answer is active circulation or mixing. And active means you're mixing that tank 24/7. You're not just mixing it when you fill the tank. Does every tank need it? May not be. You might have enough turnover, enough situation where you don't get thermal stratification, but we do know thermal stratification is pretty much in most tanks you're going to come across. Eliminate water age issues, minimize biofilm regrowth. Keep that tank mixed. Improve disinfectant, residual and stability. results in quality, consistent quality and chemistry throughout that tank. Okay, so you looked at it, you checked your water quality out of the plant, you know that's good. Water quality in the tank. Done your housekeeping, sanitary security coatings, tank is mixed, you only got a representative sample. What about the water quality out of that tank? Do you have those issues? Reduced residual, disinfection byproducts, nitrification, depending on your disinfectant system. There are solutions for those things. Let's move on though. We're talking about ice pigging. Where do you get there? Quality out of the plant, quality in the tank, got consistent water quality in the tank. I know my quality coming out of the tank is good, right? Checked it, I know it's consistent. What about at the tank? When you start getting complaints, you have complaints, taste, odor, you have low residual, color problems, and a lot of times it's because you've got a dead end of that pipe, might be far out in your system, low use, might be an old system. There's a lot of reasons for that. You start looking at what the condition of that pipeline is. What are your options? Your water flush, that's one of your easiest options. What about rehab or replacement or relining? Well, that's an option, but that's a pretty expensive option. And then pigging. Does anybody pig water lines? Okay. Have. Okay. And then and there's a lot of concern about pigging water lines, and usually because their size and bends and valves and connections. So we've got an alternative. Not many people want to pig, traditional pig, whether it's hard or soft, the water line. Okay, so what's ice pigging? Well, okay, it's not that. We're not going to put a pig down your pipe. It's actually a well-developed process that's got some technology to it. And it's got a significant investment in capital, but it's our capital. So it's an innovative and sustainable pipe cleaning technology that improves water quality. The reason why I show the glacier there, we'll get into that in a minute. Okay, so what is ice pigging? We take something that's a nice slurry, and probably the best way to describe it is it's something you might get at a 7-Eleven in a slushie. Okay, it's that kind of consistency. It acts like a semi-solid, and when we control the pressure in the lines, we can make it form a pig. But the really nice thing about that ice pig is it will flow through constrictions in pipes, bends. You can put it in a hydrant and take it out of a hydrant. So the operational impact is nowhere as critical as what happens when we try to actually hard or soft pig a line. History. Developed at the University of Bristol in the UK. We have a worldwide license for water and wastewater is owned by Agbar. And Agbar and Utility Service are affiliated companies. So through Agbar, we have a license to practice ice pigging in the U.S. in water and wastewater. It's ongoing commercial business. Actually, trial started in 2006 in the UK. Commercial business started in 2007. And it's been performed in seven countries today. So they're not guinea pigs. First trial in the U.S. Is supposed to happen right now, April 12th. Quickly, features and benefits. Combines ease of flushing, right, with the cleaning of good pigging. The ice slurry is a semi-solid that pumps like a liquid. It will not get stuck in the pipe. But it acts like a solid to remove things like biofilm, sediment, and debris. It's a cleaning process. It is not a pipe rehabilitation process. Okay. eliminates taste, odor complaints, improves residual. Removing biofilm, the other things that cause the disinfectant to be chewed up. Uses significantly less water than flushing. Flushing programs typically about four to five times the volume of the pipe. We'll use about about the volume of the pipe to flush. Big through. Again, it's not a rehabilitation process. It will not remove tubercles, and in some cases that's a very good thing, right? You remove tubercles, you can have a whole host of other problems if you're not talking about relining that pipe with steel, cast iron. It's efficient and fast, and it's typically done in one pass. What can it do? Again, remove sediment, debris, biofilm, be pumped into and out of your hydrant without taking the hydrant off. We can clean between 1 and 2 miles of pipe at a time, and it's all determined by the diameter of the pipe and the type of material that pipe is. We've cleaned up to 18-inch larger diameter pipes, and we're looking at doing larger. Some of that still work is being done. Safely clean all types of pipes. Cast iron, concrete, asbestos line, other linings, form harm linings in the pipe. What it can't do, it's not going to remove heavy corrosion, it's not going to bore out the pipe, it's not going to rehab the pipe. We don't believe it will remove hard water deposits. Achievements to date, including over 150 miles of pipe, up to 2 1/4 miles at one time, potable water and raw water, sewer networks, but force mains only, all materials, and then the operational range again. And actually, we can go down below 6 inches, that's not a problem, up to 18 again. We will test for how much sediment we remove, and kind of an indication or example is we took out 70 pounds of sediment per mile of pipe. Just an example of, as we run the process, we'll take samples. You see the front sample's clear at the beginning. As it gets dirty, that's where the pig's coming through. And finally, it's clear, clean, clear at the end. Example pipe with a lot of biofilm in it. Example before and after. Just to give you an idea, again, it will not remove tubercles, heavy corrosion, but there's a lot of cleaning that can be done with that pipe based on what all the material in the pipe. We're going to try to see if we can run this. Okay. Wait a second. Well, you gotta love technology. Here, let's go to end the show. Let me try this. Guys, bear with me, I'm sorry. All right, you know what? I'll just talk through this. That's probably the last thing you want to hear me do. Everybody hear me? No?
Are you on there? Light's not coming on. Speak up.
All right, I'll speak loud. My wife always tells me I have a very loud voice, so hopefully you can hear me now. Bottom line is, initial gentleman, the bald-headed gentleman, got about as much hair as I do. He's with a water system in Holland, and they have terrible problems with biofilm in their pipes. They've tried everything, flushing, pigging. They can't really pig. They've tried air and water together, and the biofilm actually clogs the customer's meters. The only thing that's worked for him is ice pigging. Now we moved into how we produce ice. We actually add, saw a minute ago, salt bag. We add salt to the process to depress the freezing point. We don't want the ice to coalesce in the pipe or in the truck, in our storage vessel. We add a specific amount of ice, salt. We make the ice to a specific concentration. And the ice maker and the delivery unit are mobile, so we can take it anywhere we want. The water we use is going to be basically water from our customer, so it's going to be potable water. It's going to be chlorinated. And like I said, we do take samples. One of the things we do, yeah. Working. At the end of the process and the outflow, the waste is going to go and be disposed as our customer wishes. We can either send it down a sanitary sewer, we can send it down a ditch, we can collect it in the truck. We will dechlorinate flushing water. We don't have to collect the flushing water. We test at the outlet. We will test for temperature, pH, conductivity, and turbidity. Again, we're adding salts. We know by temperature and conductivity when the pig is coming through, and we know when it's flushed out. Again, it was developed at the University of Bristol. It was initially developed to use in the food processing area, where they wanted to recover product out of the pipes, clean it, make it safe. And he's describing how it was transferred from that, being the food processing industry, to the water industry. In a minute, you're going to see some examples of it being added to a pipeline in a lab, and then out at the service center, where we've got a more standard size pipe. It has a plexiglass section, so you can visually see the ice pick up the sediment. And what he's saying there is basically the ice will form a solid, but as soon as you push on it, it's going to flow. Okay, so he's added ice to a line that's been flushed with water. We've added sand to the bottom of the pipe. What happens is that the ice actually picks up the debris in the pipe and carries it out. You'll see in a minute that he's going to go through a change in diameter and elevation, and the sand's just going to be carried up through the pipe and out the other end. Okay, that's why we were showing a picture of a glacier. We're actually picking up and transporting the debris, not bulldozing it. And it comes out the other end. The debris biofilm gets basically encapsulated by the ice, picked up and carried out. So now another example showing flow rates of the water flush. Then again, the ice slurry, one thing we have to do with the process is we're going to use valves front and at the outlet hydrant to control pressure, make sure we form a pig. The ice will tend to want to float away if we don't. So we do control pressure so that we control flow and control how the ice behaves in the pipe. Once again, you can see the debris in the pipe picked up and carried out. There's about another minute left. What you're going to see next is it's going to be back at the water system in Holland. They're going to show you that they've cut out, they'll have cut out a section of pipe and inserted a clear piece of pipe so you can see it actually working in the piping of the system. And after they do the cleaning, they're going to cut out another piece of that pipe and compare visually how it looked before and after. And again, their problem with biofilm, they actually don't add chlorine in Holland. They do everything by turbidity. And the biofilm actually breaks off in the pipe and it clogs the customer's meters. Keeps them from getting water. And you see how clean that pipe is now. Okay. So I think I can control it now. Oh, that's right, I gotta go back. Sorry. Okay. Guys, thanks for your patience. Technology always can be great when it works. I said there's a significant investment on our side on bringing the ice to our customer. Yes, we make ice, but we do control the conditions it's made in. We control how it's made. We can't leave the ice sitting for a long period of time or it starts changing shape and structure, changes how it behaves in the pipe. We'll produce that ice typically near your site. We'll bring it in an insulated tank, and that then means pumped into your system. Mentioned at the outlet, we do test the water quality at the outlet. Partly so we know when the pig has come through, we know how, if we have to collect the pig and all sediment and debris in a truck, we know when it's coming through, we know when to switch a valve, we'll send it to the truck. More importantly, we know when it's passed through. We know it by conductivity, and we know it by pH. We're also checking turbidity. I said pH, I meant temperature. So what does a typical project look like? We're going to bring all the equipment. We're going to bring enough ice to pig the line. The amount of ice we bring is dependent on the line, the length of the line, and the diameter, and the type of material. We'll test the water, and as I said, in the waste exiting the pipe. We'll dispose of it as required by you, the customer. We're not going to tell you how to do it, you're going to tell us. Based on your regulations, by state, whatever your local ordinance are. We'll dechlorate any flush water as needed. And for you, the customer, you're going to have to, again, tell us how to dispose of that waste. You're going to have to isolate the pipe section. We're not going to be turning valves. That's all your job. You're going to handle all your customer communication. And then, traffic controls, typically another part. We got to bring a truck alongside with a hydrant, and depending on what the street looks like and where it is, we have to worry about traffic control. So, in summary, It's an effective water quality management tool. It's a cleaning process, not a rehabilitation. It can eliminate color, odor, taste, improve residual. And we're not telling you you're going to ice pig all the lines in your system. The reason why you're going to look at ice pigging is because you have a problem, you can't flush, you can flush, but it doesn't work, or maybe you can't flush because of either the location or water restrictions. And that's probably not too much of a problem here in Minnesota, but out west it certainly is. It's low risk. You're not going to plug the line. We're not adding chemicals to the pipe. Okay, we're not stirring up sediment, as in flushing, picking that sediment up, debris, and taking it out of the pipe. And it's operational ease. Going in through a hydrant, out through a hydrant. We're not changing fittings. And typically, once we start pigging, it's 20, 30 minutes, depends on the line size. It's that quick. We can do it at night, we can work around your schedules, whatever makes it work. And it's now ready in the U.S.